Okay, as we've said multiple times, okay, and this is my theory as a math teacher for years and years. I think most of math is learning how to do something and then learning how to do it. You will undo it. You will be amazed at how many times, if you go on and take calculus, maybe take something beyond that, there are a ton of times where we do something and then we just undo it. And if we've got a process for doing something and undoing it and understand it forwards and backwards, we're probably in pretty good shape. So if we multiply these two binomials, again, we did some of this yesterday, but this is slightly more complicated because we get an x squared, then we get a 5xy, then we get a minus 4xy. So we've got more than one variable here. And then on the end, we've got y squareds on this one. So this is going to be a negative 20y squared. Just like normal when we multiply two binomials together, 2 terms times 2 terms is going to make 4 terms. This doesn't always happen, but most of the time we get some like terms. It does happen right here. Those are like terms. So I end up with an x squared, a plus xy, and then a minus 20y squared. So that would be what we get when we multiply those together and simplify. So, little mathematical riddle here. Got to be good at these. Now, if they're gigantic numbers, we might at the end, we might let somebody show us a little techno help for this. But we should be pretty good with fairly small numbers. So multiply to be positive 48, combined to be negative 19. I want you to stop and think about that for just a second, because there's more than just let my mind go wild and guess at this. They multiply to be a positive and they combine to be a negative. Without telling me what the numbers are, can you tell me something about the numbers? Zach?
Both of the numbers that are combined will be negative.
They both have to be negative. The ones we combine have to be negative because they multiply to be a positive and yet they combine to be a negative, so they've both got to be negative. If we think of the number 48, what jumps into most people's mind is either 4 and 12 or 6 and 8. 4 and 12. Can you make a 19 out of those? No. So if 4 and 12 popped in your head immediately, you can't make a 19 out of those. If 6 and 8 popped into your head, they multiply to be a 48, but you can't make a 16 out of those, no matter what the signs are. Okay? So a little bit of a unique factor. What would work here? D?
-3 and -16.
-3 and -16. Okay, so not the normal way we'd make 48, but it'll work on this one right here. So -3 and -16. Multiply to be -40, combined to be positive 18. Multiply to be -40, combined to be positive 18. Again, saying the sign of the number in front there, it's got some important information. Without telling us what the numbers are, can you tell us something about the numbers? Sai. One's negative, one's positive. He's right about that. Can you tell us anything about the relative size of those two numbers? One's positive and one's negative. Can you tell us which one's got to be which without telling us what the numbers are? Samara?
The bigger number is going to be positive.
The bigger number is going to have to be positive because when we combine them together, it's going to have to be positive. That one's going to have to win, so to speak. So I need two numbers that multiply to be -40 that combine to be positive 18. Crew, what do you think?
It's 20 and -2.
It is. It's 20 and -2. And again, if you take just a second to double check yourself right here, do they multiply to be -40? Yes. Do they combine to be positive 18? Yes. As long as we're careful with whatever work comes after that, then we're going to be just fine. So what we're going to do today, I think we've only got 4 problems to do here. They're just a little bit different. They're still trinomials. They've still got some quadratics in here, but they're a little bit different. So I want you to take a look at this one. X squared plus 13xy minus 14y squared. So the only way to make an x squared is to put an x here and an x here. Okay. The only way to make a y squared here would be to have a y here and a y here. When I say the only way where we could possibly come up with a middle term that has an x and a y on it. What are the numbers? Or better yet, what question are you asking yourself right now? If you want to finish this off, what question do you have to ask yourself? I need some numbers that think for a second. That's the part of our brain that gets worked out and stretched. We learn something, we grow, synapses connect, we make some new connections. Lizzie, you had your hand up. Did you want to try?
Well, they need to combine to be positive, but then multiply to be.
Perfect. They need to combine to be positive, multiply to be negative. Specifically, they need to multiply to be negative 14, combined to be positive 13. Anybody want to tell us what they think they are? Angela?
14 and negative 1.
Okay, I'm assuming positive 14, right? Okay, positive 14 and negative 1. So if I put those right there, and again, as long as I move the negative y over here or the 14 over there, okay, they're the same factors, commutative property there. Let's just double check and make sure. Do they multiply to be x squared? Yep. Multiply to be negative 14y squared. Yep. Here's the important part. We'll check this just like we did yesterday. These are going to multiply to be negative xy. Those are going to multiply to be positive 14xy. Will they combine to be positive 13xy? They will. So we are done right there. That's it. Whoops. I need to draw slower. Mason.
So when we're doing binomials like this, will we always be able, when we group them out into two binomials, and group out the hard trinomials into two binomials and simplify, will we always have two common factors on the inside?
Okay, so everybody listen. Look, I know you're working ahead. Just stop for a second and listen. Okay. Here's Mason's question, if you were paying attention to what he said. He said, if we do this technique, and let me make sure that I've got this right. If we do this technique, whether we do it by the riddle method or the grouping method, which is what we're going to have to use on this one because this is a hard one, will we always end up with two common factors that we can then pull out and then it factors completely? The answer to that is yes. If this this question has an answer. So this is a hard trinomial, right? Caleb, can I take anything out of these? No. Nope. No numbers and no variables. We've got a mix of x's and y's. Nothing has everything, so we can't take anything out. So we're going to multiply here. These are going to multiply to be 20. If this question, what multiplies to be positive 20 and combines to be positive 21, if that question has an answer, then we know it's going to work out. So I need two numbers that multiply to be positive 20 that combine to be positive 21. Crew?
20 and 1.
20 and 1. Double check right here, because it's a horrible shame and it's frustrating if we get halfway through a problem and realize, oh crap, I got the wrong numbers. Do they multiply to be positive 20? Yes. Do they combine to be positive 21? Yes. If the answer to both of those questions is yes, this is going to work every single time. And it doesn't matter what order we put them down. We're going to break this into two pieces. If you want to write 1xy first, great. And 20xy second, great. If you want to flip them around and do 20xy here and then 1xy here, that's totally okay. So I've got a 2x squared. Make this look right. 2x squared plus that, plus this, plus 10y squared. And then I'm going to start taking things out. I can take out a 2 and an x. I'm left with an x and a 10y. And I can take out, Andy, what am I going to take out?
A y.
I am going to take out a y. What else? And a 1. What kind of 1?
Positive.
A positive. Okay, so make sure you write that. So if we take out the y, we're left with an x plus a 10y. And there's that common factor that Mason was asking about. We've got a 10y and an x plus 10y in both of them. So I've got a 2x plus y in the other one. Circle that and we're all set to go. Any questions? Okay. Is it okay to write 2x plus y first and then x plus 10y second? Totally okay. Okay. Why does this have an asterisk by it? Wilson.
Because it's the same as the last one we just did.
It is almost the same as the last one. What's different about it?
It's flipped, yeah.
It's flipped. Is it still a hard trinomial? It is, because you can't take anything out. You're not going to be able to turn that into a 1y squared. So this is still going to be 20 and 1. So we're going to do 10y squared plus 20y, or sorry, xy plus xy, and then plus 2x squared. So you can take out a 10y. That leaves me with a y plus 2x. I can take out, let's see, I've got an xy and a 2x squared. So I can take out an x. I'm left with a y plus 2x. And this always makes us feel good at this point. And this, again, goes to Mason's question. We got some things that look the same. So I can take those out. And I like writing mine like this. Pull the common stuff out front and write down what's left at the end. That's the way I usually write it. So I'm representing those with one factor right here and then writing down the terms that are left right there. But you could switch it around if you wanted to. Okay, Mason.
So if we were to do this and there wasn't a way, okay, so before we started, would there be a theoretical situation where we want the term with the largest coefficient to be in the middle?
No, it works out that way because these are all positive, which was a point that I was going to bring up. If there had been a negative sprinkled throughout here, it would have made this a slightly more interesting problem. Okay, but nice theory there, Mason. Take a look at this one right here. Hard trinomial? Sure, technically. I'm going to go through and do this. I want you to think about this, though. Seven times 1, -7. Careful on the signs. I need some numbers that multiply to be -7 that combine to be -6. Keely? Do they multiply to be -7? Do they combine to be -6? You're close. We just need to fix one thing. And these are the mistakes we want to avoid. So just fix it with, what do we need to do? Yeah, just switch the sign right here. We need a -7 because if it combines to be a negative, the bigger of the two has to be negative. So I'm going to write 7c squared. Ooh, let's see. Something else about this. Can I write it this way? Take a look. -7c plus 1c. I'll write it like that. Minus 1d squared. I'll write that. I can take out a 7c. I'm left with a c minus 1. What can I take out of here? I can only take out a 1. And what I'm left with is a c minus d squared. Okay, now, so here's the deal. We got answers to our question that should have worked, but there's something else going on here that makes this a little tougher. So this goes to the question at the very bottom of the page. Oops, I need to make it this big. Okay, so here's the question. Those all factored. We had this nice, cool pattern that worked out, the trinomial grouping and everything, the hard trinomial, we're multiplying the coefficient of the first one with a constant at the end, all that sort of stuff, and it works out. But this one doesn't. So there's got to be something other than just the numbers that make these factor. So I want you to look at those first 3 examples, then I want you to look at this one. What screws this one up? What makes this one so it's prime, even though we got an answer to that little riddle? Got some hands up. Don't let somebody else do all the thinking and learning for you. Here's what it is. When dealing with trinomials with more than one variable, how would you describe what to look for? What do you look for the variables in the leading, middle, and last term? How do they have to compare? Because we got 3 examples, and one that's jacked up that doesn't work. So how would you describe somebody what we're looking for? Why do those three work and why does that last one not? Colson, what do you think?
So first they have to be squared, the first and the last one. But in the first one it can only have one variable and the last one can only have one variable. But the middle one has to have both of the variables.
Okay, so this one's going to be, we're going to look for squared variable in the first one, squared variable in the last one, and the middle one has to be mixed, or we could say both, or we could say one of each. So the thing that messed up this last one is not the numbers. It was the fact that this middle one didn't have a D on it. If it did have a D on it, would it work?
Yeah.
It would work. It would fit the pattern. Yeah.
So what would happen if the center variable was like squared?
So it's got, and we'll look at these types of patterns tomorrow. But if this one's squared, the middle one has to have that plain old, just a linear term we call it. If this one's squared, it has to have a repeat of that linear version. So if this is y squared, square root of that would be y. The middle one needs a y. If this is an x squared, the middle one, square root of that is an x. The middle one needs an x. So if the middle one had an x squared in it when it didn't need one, we wouldn't be able to factor it. Okay. Good news is most of them are like these three right here. Okay.
That B is just the same thing flipped as the first B.
It is. Yep. And the difference is, though, if you take a look here, you'll notice that we've switched the order. And this, again, is why I said if this had a negative in it, it would have worked out very different. You couldn't just take these and switch them around however you wanted. Okay. So we could do this front to back or back to front. Either way is fine. Everybody good? Okay. Not quite done yet. Okay, I want you to flip the page back over to what we did yesterday. Actually, take it back. It's at the top. It's at the top of the page. Now, some people yesterday did this one the hard way. They multiplied these together and they got negative 720. Okay, huge hassle. Okay, I think we made our point that if you take out the GCF, it's going to make the numbers and the variables smaller. It's always going to make our job easier, right? Okay, Luke, do you have a way that you can use technology to help you factor these?
Yes. So if you open your calculator, you go to table. You have the regular x's where you've got 1, 2, 3, 4, etc. So what you do is go into y, and you put x divided by whatever number you're looking for. So let's say you want to figure out what goes into, what was the number negative 720.
Mm-hmm.
So we would put y1 equals x divided by 720,
You all following that?
or negative 720.
Okay, here's my question, Luke. Did you think of this yourself?
I did think of this myself.
He did think of it. We're gonna modify what he thought of, and we're gonna improve it a little bit. So here's what I want you to do: go to the y equals menu and clear everything off. Okay. What we want is numbers that go into 720 evenly, right? Negative 720. Okay, so I'm going to take negative 720, and you can modify this even more. Divide that by x. Okay. Hit second window. That'll take you to the table. Okay. You can play, I honestly, I don't use this. Okay. You can start with 0 and go by ones. That delta table just means the difference is going to be 1. You can leave it on auto, or you can tell it to ask. I'd leave it on auto for the time being. And we're starting with a gigantic number, so you'll see what I mean when we get there. Now hit second and table. And if you run through here, here's a list of numbers that you could use. Okay? And you only want to use the ones that work out with nice integers. So I need some numbers that multiply to be 720, negative 720, and combine to be negative 6. So 1 and negative 720 aren't going to work, but if you go down the list, these are getting closer and closer together, and you're going to get to the point where, let's see, well, those would make a negative 22. We keep going down here. There's a negative 20 and a negative 36. there's a 24 and a negative 30. Okay. Now, is it worth it for 720?
No.
Yes.
Great. I don't think it is. Okay. It might be. Is it worth it for 48 and combined to be 19? No. Okay. So if you get in a pinch, you can use that. But I would much rather you work on those general skills of remembering, hey, what multiplies to be this, combines to be this, remembering some of those basic facts. 99% of the time, the numbers that we work with are going to be way quicker than that. Now, if you get in a pinch and you got some big numbers that are really nasty, by all means do that. So again, we're going to take, and let's flip over to the other side. What was another one that we did? Let's do this one. There was no way to get out of this. So I'm going to go back to y equals, what's going to go on the top? 36. So I'm going to do, 36 divided by x. I'll delete everything else off. I could have hit the clear button, I suppose. Go to the table. And if you use this for more than one thing, it's kind of a hassle because you have to go back and forth. If you're interested in knowing how the ask thing works, you can come up and I'll show you how the ask thing works. My calculator gets way behind when I push the buttons too many times. Okay, we're looking for numbers that multiply to be 36 combined to be some form of 13. 1 and 36, 2 and 18, 3 and 12, 4 and 9. Wait a minute, a 4 and 9, you can make a 36 out of those. So the caution about this technique is it won't give you the signs all the time. Okay, if they're going to multiply to be a positive and combine to be a negative, you're going to have to provide the signs on those. But at least gives you a quick list of all the factors that go into all the even factors, all the integer factors for 36. Everybody good there? Okay. Cool trick, in my opinion. I learned about this a couple months ago. Somebody else came up with this. I didn't figure that out. Luke came up with a way that you could type it into the table. Great. Okay. Probably, depending on the situation, probably not worth it. Okay, any questions? Okay, I'm going to stop.